Okay, so after talking to everybody, I think we all hate Perforce now. So let's try this. Let's go on to Assembla, and I love how the default login page for Assembla is error code off failed. So every time you click on the login link, number one hit, your login was unsuccessful. Please try again. Fantastic. So
I love their error codes, don't they?
Yeah. So come on to Assembla here, and we have our repo here for any. And so I'm actually just going to make a new repo. What do we got here? Invite members. Nah, I don't care. Go away. Go away. All right. Nope, not you. Not you. You. New repo. All right. So I'm going to call this new. My repo name is going to be Laser Zombies Resurrected. And I'm going to try this with svn. Git is really good for handling source code files. It's not great for large digital assets like for game development. So let's try svn. Let's just give it a shot. So create an empty repo, and we got Laser Zombies Resurrected, and here we go. So can I invite all of you into it? Maybe I can. Maybe I can't. I don't know. So what I will do is this will be your next homework assignment on top of your other homework assignment. I'm just going to try adding all of you to this repo here, and I just want you to upload a file. And so that'll be, let's see, SVN client for Windows. I haven't used SVN in like 10 years or so. Tortoise SVN, I've seen people use that in comparison to Subversion clients. Yeah, I'll dig into this a little bit, and I've seen a lot of people using Tortoise. Maybe we'll just do that one. So let's see if we can do this. Instructions. Start working through your thing. Copy. Commit your code. Start working with it. Start with SVN. Okay, so I'll run you guys through this, or I'll just maybe link this to you. So here is maybe that there. That's the link. That's Tortoise SVN, and here is the directions. And so let's try this out instead of Perforce and see if we get the same sort of issues that we had with Perforce, because Perforce is kind of pissing me off. It might be because I don't have a lot of experience with Perforce, and that's entirely possible. I do know there's ways of renaming files without having everything explode, but I do also know that if you do it the wrong way, you don't follow the right way, then everything explodes, which is not, in my opinion, good design for a repository.
Or else everything explodes.
Yeah, if things regularly explode on you, and to be fair, if you don't really know what you're doing that much, then maybe, just maybe, your system's badly designed. So, there you go. There's that. If you guys can all message me your email addresses, I will add you on the team here for Laser Zombies Resurrected, the 2.0 version of it, and we can work on that offline. So I'm going to put up another mini assignment. All you're going to have to do is upload a texture or something to it, and then just upload a material or something that has your name on it, and that's how you'll get the points for that. Okay? So, any questions about that part?
No, that should be it. So we're transitioning to SVN.
Yeah, we're gonna try SVN out. We're gonna try SVN out, and then if that works better, then just switch to that for all of your synchronization stuff, because I'm kind of reaching my limits with Perforce. So we'll give that a shot. Okay. And yeah, and so now that the game jam's over, we can actually work together on projects and things like that. So yeah. So Dolan, you're free to work on their group, because they were at 5 people before. Or you can continue contributing to Laser Zombies Resurrected.
I have a proposition. I want to propose something. So
Sure.
Here's something I've been really thinking about.
Mm-hmm.
As in IS-50B, ever since IS-58. I was wondering, so is there any chance, so I know you guys said that it's difficult to use C++ code in Unreal.
No, not really.
I was wondering about, would it be possible to probably at least give that a try in this
Yeah.
class, because I kind of want to give it a try, maybe expand myself in C++ through Unreal and
Yeah.
experiment. Could I do a project that is a C++ project rather than using blueprints?
Yeah, we can do that. In fact, what we're going to be moving to next is actually C++. Not on Unreal Engine, but on the server. You guys never did the Voroni code, did you? Or did you?
No.
You never did Voroni.
No.
Yeah. So that's
we didn't do.
that's your next homework assignment. That'll be due on Thursday. It's really easy. So what Voroni is Voroni regions. What it is, it's a way of like marking which areas on a map are closer to a point than any other areas. Yep. So if you've got, come on internet, don't fail me now. So if you've got these cities here, then these regions are the areas closer to this city than this city. Do you guys understand? So you can.
I remember seeing this in my last thing during the summer.
Yeah, and so so Voroni is used in a lot of different circumstances. A lot of areas where you wouldn't think to use them. Voroni map of the U.S. So if you take every capital and do a Voroni diagram of it, basically this is dividing up the America based on which parts of the country are closer to a capital than any other capital. Okay, and it looks kind of weird, huh?
Yeah.
It's interesting.
Yeah, it is cool, but like, yeah, you can use Voroni Teslization to create these cool patterned things. Like I've seen it used to make cobblestone patterns and things like that. So rather than having just a uniform cobblestone that is just very regular and unnatural looking, you can scatter Voroni seed points on a surface and then run the Voroni algorithm on them and create these patterns. And then basically wherever the edges are, you do like a normal map or something you can curve them and curl them down and things like that, or displacement map. And then you've got these sort of irregular cobblestones that nonetheless fit together really nicely without gaps in them. And you can use them for world building. So that's pretty cool.
Like building frames for like infrastructure in games.
No, like making a new map, like this.
Oh, so map building or like.
Yeah.
Or?
Yeah, so like for like Dwarf Fortress or these kinds of things, you can start by scattering seeds on it, doing a Voroni Teslization, and then you can then there's other things we'll learn about, but that, you know, you can see you can make
So it's used for
random
train
maps.
generation?
Train generation, yeah, exactly.
Oh, so like Minecraft.
I don't know how Minecraft does it. I don't know if they use Voroni or not.
They use a similar system though.
Voroni
But
train
like,
generation.
plain.
And then I've seen hex games made using it. But basically, yeah, the algorithm's actually really easy because we're going to be doing it on a grid. And so you start off with like a bunch of just randomly scattered points. And then you colorize each point on the map based on which city is nearest to it. So, pretty easy. And there's a lot of really cool looking stuff you can do, you know, using Voroni Teslization. Yeah. Procedural landscape generation, all this kind of stuff. So, yeah, we're 2D top-down maps and things like that. I've seen it used for like making rivers and like all sorts of Delaunay triangulation is the same thing as Voroni, by the way. If you ever see Delaunay triangulation, it's on a fractal, but this is actually the same computation as the Voroni. It's in some ways the inverse of it, but it's essentially computing the same thing. So there's all sorts of really cool algorithms you can use to make all sorts of procedurally generated stuff. And so we're going to do the most basic version of it. And so you guys all have accounts on...
Dwarf Fortress?
What's that?
Programming Dwarf Fortress?
We're not programming Dwarf Fortress. We're programming Kearney Kingdoms.
Bernie Kingdom.
That's correct. Yeah.
I like it already.
Voroni Castle. Wait, no. That's a totally different thing. Okay, CD. Voroni. Alright, Voroni got reference. So when you run it, it starts off by scattering random points on the map, and then it colors the cells in the map based on which city is closest to it. Each city is given a randomly generated color, and then the cells are simply colored based on who's nearest to it. So you can see, like for this point here, where my mouse is, it's closer to I than it is to D or B or A, so it's colored pink. And so all you got to do is do a 2D loop for every row, for every column, compute the distance, do brute force. There's much better algorithms for doing it, but you don't need to worry about it. This is fast enough for our purposes. For every point on the map, do a Pythagorean theorem. You guys remember the Pythagorean theorem?
A plus B squared equals C squared?
Yep. Or in C++ the standard library, it's called hypot. And so just hypot, this Pythagorean theorem, the distance from my row and column to every city's row and column, and find the one that is closest. Whoever is closest, that's my color. Done. You guys got 2 days to do this. So, Voroni. So let's go through the C++ code. Do you guys all have accounts on the server? Hypot, yes. It's not. It's that's a different kind of hypot, Dolan.
Yeah, I kind of wish I was at home with my 2 monitors so I could somewhere monitor.
Okay, I'll head on to the server right now.
Do you guys all have accounts? I should ask you that.
I don't know if I have an
Yeah, I have one for CSI 26.
I don't have you this semester.
Okay.
I can make another folder. So.
Okay. Let's see here.
Yeah.
CD vim is 50 summer. No. Vim is. I'll take care of it. If you don't have an account, message me, and I'll set you up on the server. Okay. Let's go through the source code here. So you're going to be. You've all had me before for coding, I think. Maybe not Spraggins. Spraggins, have you done C++ coding before? Austin?
Yeah, I think Dolan is.
What's that?
Is Dante still in the class running?
I don't know. I haven't seen him drop. So, all right. So let's go through the C++ code, and this will be. I'll get everyone set up on the account offline. Got 20 minutes left in class. So this is how you check to make sure you're using C++ 17. Compile.
Sorry.
So if you are not using C++ 17 or above, then it will throw an error. It won't compile. It'll say, sorry, sucks for you, compile with -- stud equals C++ 17. These are typedefs. So typedefs, it's equivalent to using S8 equals int 8_2. Same thing as that, basically. So you'll see in game development especially, you'll see these aliases. These are type aliases. So in C++, there are different kinds of integers. There's signed integers and unsigned integers. Unsigned integers have a U in front of them. Signed integers don't. And there are 8-bit integers, 16-bit integers, 32-bit integers, and 64-bit integers, signed and unsigned. And so it's very common in video game development to see people abbreviate them to S8, S16, S32, S64, because using int is ambiguous, right? If I said int, whoa, what just happened there? It just exploded, yeah. Int owner equals 0. So how many bits is int? I don't know. Minimum of 16, maximum of 64? Who knows? Probably 32. Might be, might not be. And in video game development, you very rarely want to be surprised with how many bits something is. Like, you usually have a pretty strict need for a certain number of bits, right? If you're going to be holding dollars, you don't want the dollars to sometimes be 16 bits, which is a maximum of 65,000. You'll be badly surprised if you go on a system that whose ints can change. And so it's very common instead to say something like this, where you just say, give me an unsigned 32-bit number. And you'll see this all throughout game development. Okay. And then
So it's like a weird.
this is like I said, this is actually an equivalent to saying unsigned int owner equals 0.
Oh.
These two things are the same thing, actually, on our system, because it's a 32-bit. But this is what's called a type alias. So it's type defing unsigned int 32-bit type to be U32. So it's creating new types. This one called U32, and that means it's an unsigned 32-bit number. And the reason why I created it for you here is so that you get used to seeing it, because when you move into C++ and Unreal Engine, they have a similar sort of system set up. And so get used to seeing things that are not int. You know, it'll be like int 64, unsigned int 64. Like, they're usually pretty precise with those things. So we've got a big 2D array that holds the world. And so this is a tile-based world. So like if you ever played like Age of Empires or any of these Diablo or any of these top-down 2D games, a lot of times the world is held in a tile-based system. So there's just a big 2D array, and the player can be on one tile or they can be on another tile. In Diablo 1, you were always in the center of a tile, so if you click somewhere, you'd always move to the center of that tile. Diablo 2 allowed you to move around within a tile. You're still in the tile, but it made the graphics smoother. You transition from this part of one tile to this part of the next tile to make it look like you weren't just doing tile-based movement when you were. So every tile in our world here in Creating Kingdoms is going to have one city that owns it. And that city is going to be an index. So it's going to be 5 or 10. So city 5 or city 10 owns me. And what that is an index into is that vector right there. So there's going to be a list of like 15 cities or something. And every tile, what your code is going to do, it's going to go through and fill in who the owner of each tile is. So for every tile in the world, it's a big 2D array, like a big 60 by 30 array, something like that. It's not that
vector,
big.
right?
What's that?
It's a vector, right?
It is yeah. It's a 2D vector. I just use a 2D array.
Oh.
Same thing. So you access it the same way as a 2D array. So you have a big 2D array of tiles, and every tile is going to have an owner, which is the index into the city list here, and it's going to have content. For most of them, it's going to be 0. But for the actual city itself, it's going to have the letter. So capital T, capital B, whatever. So that's the tiles just basically hold who their owner is and if they have a letter on it or not. Later on, we're going to do more with this, but for now, the tile is either blank or it is it's got the capital on it. Okay, and then we've got this class here called city, and I don't know why it's a class. It could be a struct for all we care. And so it's got a constructor that is going to give itself a random color. So red, green, and blue value randomly set from 0 to 255. Its home row and home column are set to 0 by default. That's going to be set later on. And then this thing here I just put in there to teach you guys C++. You should probably pull it out. But what this is a static variable. So it is a variable that is attached to the class and not to members of the class. So in other words, all objects of type city share the same variable. So if one of them writes to it, the other ones will read it. And if somebody else writes to it, everyone else will. So when these people add to the count over and over again, the name of the first city is going to be Fresno 1, the name of the second city is going to be Fresno 2, Fresno 3, Fresno 4. Even though they're all different cities, they all share the same static variable. And so they're all going to know which... it's basically used so they can all not have the same name, really. And the row and column will be set elsewhere. And then we're going to have a vector of all the different cities in the world. So if we have 20 cities in the world, the vector is going to be of size 20. You have to write a print world function that says for every column, for every row, for every column, print the color of that tile. Okay. there is a function called set background color that takes in the red, the green, the blue, these values right here, and it'll colorize them. That'll change the color. So you set the background color and print a space. Basically, you're going to be doing something like this. Like set BG color 100, 200, 100, like that. See out a space. Of, I don't know what color that is. Color is that? R of 100, green of 200, blue of 100. It's like a, I don't know, some kind of green. Some sort of line green. Okay. So you're going to, so you are going to do the above in a doubly nested for loop. Okay, so you're gonna get the color of the city owner. Coming down here, welcome to Voroni Kingdoms. How many cities do you want? And so the user will type in like 15 or something like that. And then it's going to print out all the names of the cities. You can make a better set of names rather than Fresno 1, Fresno 2, Fresno 3, things like that. I'm going to go ahead and mute Aaron because I keep hearing noise coming from him. So it starts off by printing the names of all the cities. You can come up with better names than that. Don't worry about naming the cities at first, just worry about getting the code work right. And so this code here is all done for you. This basically makes it extends the vector to be a 2D vector with number of rows, number of columns. And then you're going to write a Voroni calculation. The Voroni calculation says for every tile in the world, for every row, for every column, for every city, find the city that's nearest. So it's going to be a triply nested for loop. That's what you have to write. That's basically your homework assignment. You have to write a triply nested for loop. For every row, for every column, this is how many rows there are. This is how many columns there are. This is how many cities there are. For every row, for every column, for every city, find the city that's closest. And once you find the city that's closest, set the owner of that tile to be the index of that city. So we have city list that holds, let's say, 15 cities in it. So if city number 12 is the closest, then at example, this sets the owner of tile row 10, column 30 to be city number 12. World.at 10.at 30.owner equals 12. You're going to do a big triply nested for loop. You're going to find out which city is closest using hypot. Hypot, a function that says the Pythagorean theorem. So you're going to set the owner of the tile to be whichever city is closest. You do all that, then you call print world, and print world is going to do a doubly nested for loop for every row, for every column. Print the color of the owner. Get the owner, get the color of the owner, set the background color to the color of the owner, and print a space. At the end of every row, hit return, hit enter. And that's it. Do you guys think you can do that in 2 days, or do you want a week for it?
How big is the screen?
What's that?
How many tiles?
How many tiles are there? I don't know. However big your screen is.
And I'll I'll always ask for a
100,
if you want them in 2 days.
110, 120, something like
Yeah, end of the semester.
that. End of the semester.
So if you do the for loop, you gotta find out how many times you gotta iterate.
You have all those numbers. This here is how many rows your screen has. This is how many columns your screen has. And I'm already resizing. I'm resizing the world to be rows by columns or columns by rows, whatever. Okay.
Yeah. So can I just ask a question about the high pot function?
Yes.
So is the idea that so the triple nested for loop comes from the first and second one are just to find each position on the grid,
Mm-hmm.
and then the last one you just compare the hypotenuse of every single city, and then you just take the smallest one.
Yeah. For every tile on the world,
Yeah.
go through every city and find the one that's closest.
Okay.
So you take my tiles row and column, and do a hypot. It's something like this, right? It would be like float distance is equal to hypot my row, which is probably going to be like I or something like that, minus city row my column minus city column.
Yeah. And then you just take the shortest one. And then
Whichever city has the lowest distance, that's the owner. So you do something like that. That's the Pythagorean theorem. I'll sketch it out graphically, I guess.
just curious, does high pot always return positive? Like, is it just a
Yes.
distance?
Yeah, there's no such thing as negative distance.
Is hypot a part of the standard library?
It is now. Yeah, it didn't used to be. It was added in C++ 11, and then in C++ 17 they added in 3D hypot, so you can do X, Y, and Z.
Oh,
Yep, pretty cool. Let's see.
interesting.
Yeah. It's not a function a lot of people know about. It's not something that Jedi would teach you. Okay, so let's say we've got our... in our world here, we set it up. It's a... there are 5 columns, and there are 4 rows. Okay? And so we've got a city here named A and a city here named B. Okay? And we want to see who owns this spot right here. Like we're iterating through our doubly nested for loop for every row, for every column at that tile. So what is this? For every row, this is like I, and this is like J or something. 0, 1, 2, 3, 4. So this guy's at 1, 3. This one's at 3, 0. And then we're trying to see who owns point 4, 1. Okay, you can eyeball this and you'll know that B is closer than A, but let me run you through it. So you're gonna do this computation for every point, for every tile in the world. You're gonna do this computation. That's why I said it's a triply nested for loop. For every tile, you're gonna do this loop here. So you can say for every city. So we only have 2 right here, pretty easy. We're going to do the hypot. So the first one is going to be hypot my column minus their column, 4 minus, oops, 4, 3. 4 minus 3, and then my row is 1, and their row is 3, 1 minus 3. And so this is going to return, wait, which, no. We're doing B, I guess. Let's do A first. Okay. So the distance to A is going to be the hypot of my column minus their column, 4 minus 1, and my row minus their row, 1 minus 3. And so this is the Pythagorean theorem, so it's going to be 3 squared plus 2 squared. So it's 9 plus 4 is 13. Square root of 13 is something. 13 square root 3.6. So the distance to A is 3.6. 1, 2, 3. So the distance from here to here is 3.6. Okay. And then we're going to see what the distance to B is. So the distance to B is the high pot of 4 minus 3 for the column, comma 1 minus 0 for the row. And so this is just 1 squared plus 1 squared, which is 2 squared, which is the square root of 2, which is 1.414. So the distance from here to here is 1.414. This is less than this one, so B owns this. Does that help? Kind of visually understanding what's going on?
So we're going to do a for loop for this, right?
Yes. For every tile, for every city, find the smallest.
I'll break this thing similar to this. So we're going to do an if statement checking if which one's closer, and then we're going to give it to the tile that's closest.
Mm-hmm.
Yeah, okay, we get it now.
Yep. Total amount of code. It's always dangerous telling students that because like if they write more code than that, then you feel bad. It's just sort of just to eyeball. It's just sort of to eyeball how much code it was for me. So my print world is a doubly nested for loop that was 30 lines of code, and my Voroni calculation. Let's see, that's reading all the data in. Okay, the actual Voroni calculation itself. For int I equals 0, I is less than rows. For int j equals 0, j is less than calls. 18 lines of code. So the actual Voroni calculation itself finds the nearest city, basically, and then sets the owner of the tile to be the nearest city. So 18 lines to do the Voroni calculation. And then to print it out, I guess 30 lines, even though I think you could probably do it in less than that. So.
Do you need to handle ties with that?
Do you need to handle what?
Like, so if two, like the high pipe function of two series, so like there's not one lowest value, there's two.
I wouldn't worry about it. Give you a little more starter code here. What a great comment, huh? Clear screen clears the screen. To white font black. So you can these are all functions from my colors library, and they're used to do stuff like moving the cursor around. So like you see how like VI, I can hit like left arrow and right arrow and up arrow and down arrow and things move around. That doesn't look a lot like cout does it. So that's how you can do this. This call here, move cursor, will move the cursor on the screen. Set color sets the foreground. Text color. It's like where I am here, the foreground color is white, right? Because the font is white, and then the background is black. And so you can set the foreground color and the background color like this. So you can do a doubly nested for loop, iterating over the whole world, printing the colors of the owner of each tile, one per space or something. Okay, I'll give you guys a week to do it. So due on Thursday, I'll get SVN set up, and I'll have you all just check in a file by SVN on Thursday, And Aaron, I want you to set up an SVN repo as well. I'm going to make Aaron the official leader of Team Sneakers, and I'll be the unofficial leader of Team Bluebird. And I'll just allow you guys to contribute to either of the projects that you want, and hopefully we'll have something cool that we could release in a few weeks. Okay, but we will need to get source control going, because it's super annoying to do this otherwise. And then this will be due on Tuesday. I'll give you guys a week to work on this. Some of you might not have coded in a while. I need to get you set up on the server, so 2 days is a little short to kind of work through those issues. Okay, any questions? Aaron? Let's unmute Aaron.
Oh.
Aaron, any questions?
Yeah. So Thursday we just have to submit the SVN.
Yeah, you're going to connect my Subversion repo that I just created. You're just going to upload a material with your name on it, or even your face on it. That might be kind of fun.
Well. Okay, and then you mentioned something about leader. I didn't quite grab that.
Yes, I'm making you the official, unofficial leader of Team Sneakers.
Team Sneakers.
Yeah, we have two teams.
Okay.
We have Team Sneakers. We have Team
like Waffle Waifu or something like that.
We have Team Sneakers and we have Team Bluebird. So you're the unofficial official leader of Team Sneakers. I'm the official unofficial leader of Team Bluebird.
Cool. Okay, that sounds cool.
All right.
Sounds cool. And for this assignment, for this coding programming assignment, it's not due until Tuesday.
On Tuesday.
Right?
Yeah. All you have to do by Thursday. I want to get source control. Like, you guys don't understand like how important source control is in the real world. Like, it's literally how you get all of your work done in the real world. It's really important for all computer science.
I actually kind of learned its value from using GitHub. So
Yeah,
Same here.
It's very important.
Yeah,
Very.
GitHub is like the universally used one for source code, but we're not doing source code. Get
Games.
barfs on large binaries, and so Perforce is just kind of used because Git kind of sucks at that. Like I said, I haven't used SVN in like a long time, so we'll find out how good SVN is SVN is at it. It might be good, it might be bad. Maybe all of our choices are horrible. I don't know. So
it all depends on us making interesting choices.
Yeah, we'll see how it works out. Okay.